So, day 2, 1.6, 1.7, our topic today, we're representing functions as rules and graphs, our rules and tables, and then 1.7, represent functions as graphs. We're going to really build off what we did yesterday with evaluating expressions, because you're going to do that when we are finding if a function is real. So, first thing, warm-up activity. Write an expression, 7 more than the number x. What did you get for your answer? 7 plus x, or x plus 7 when it works.
This is the answer, x plus 7.
Alright, number 2. Determine if 3 is a solution to 2x minus 4 equals 2. So, we're looking at that. What did you think?
Then I'll have to miss this.
I'll catch you up, but. What do you think? Yes or no?
Yes.
Okay, let's try it. So I put 3 in for x, so it would be like 2 times 3 minus 4 equals 2. 2 times 3 is 6 minus 4 equals 2. And 6 minus 4 is 2. So, correct. And number 3, George spent $4 more than twice as much as Casey at a store. If Casey spent $6, how much did George spend? What did you get on this one? What'd you get? Kate?
16.
What?
16.
16, let's check. So if he spent, Casey had $6, I'm going to put that there, and he did 4 more than twice. So it would be like 6 times 2, and it's 4 more. So 4 plus 6 times 2. That is 4 plus 12, which, good job, Katie, gives you 16. Alright, so it's just a little warm-up, get you in the right mind frame so we can start today's lesson. Let's go ahead and read today's learning goal. Rowan, will you read it out loud for us?
I can understand functions, I can use models to understand relationships, I can use models to understand relationships, I can solve problems in math and other contexts, I can apply/adapt strategies.
Good. So we kind of had a little mistake where we wrote that one part twice, but it's okay.
It's typed out.
It's typed out.
Yeah, it's all right. Okay, so the first thing is I gave you this little McFrayer's, I think it's called, yellow sheet, and it's going to help with our vocabulary. So right there in the middle, it should say, we're going to go ahead and write the word function in the middle. So we're going to look at the vocabulary word function, and we're going to try and really understand what that means. So the first thing is my definition. And a function is a set of pairs of input is your domain, and output, which is going to be known as your range, values where every input has exactly one output. That's going to be very, very important. I'm going to hit up on it on the characteristics again, but when we have our input numbers, like in a function table, it has to only have one output that it goes to. So if I have the input number 1, it can only go to one other value, like 3. It can't go to 3, and it can't also go to 5. Otherwise, that's not going to be a function. Derek, I need you to be writing this on your little yellow sheet, but
You told me to get my laptop out.
yep, because we're following along in OneNote. But this is part of what we're going to be doing today too.
I'm trying writing.
Write up here what it's saying there.
Wait, am I going to be writing that much for all 4 boxes?
Not really. Okay, I'm going to go ahead to the box for characteristics. And what I'm going to say for characteristics of a function, This is a good way that we can quickly do a visual and see if it is a function. So it says, if you can draw, and you guys can shorten this up any way you want, if you can draw a vertical line through the graph that touches the graph more than once, it is not a function. Oops. This is the pencil test. Try to make this a little bigger for you guys. And remember, if you don't quite get all this written, I will have this saved and you'll be able to go back into your OneNote and get it later. So mainly what they're talking about is if you can draw a vertical line through the graph. So I have my graph, and you're going to see our example and non-example here in just a second. But if I can draw a straight line, or if I take my pencil and I go along in the line that I've made on my function, if it touches more than one spot, it's not a function. We're going to do a few examples of what a function does look like, though. Real quick, let's do this. The first thing I'm going to do is I'm just going to list coordinates. This is an example of coordinates that would work as a function, such as if I had the coordinates 4, 12, 5, 15. We'll say 6 to 18, and let's do like 10 to 30. If you're looking and saying, okay, are these coordinates, do they make up a function? The answer is yes, because the x coordinate, which is the first coordinate listed, the 4, 5, 6, 10, also known as the domain, only has one point that it's going to, the 12, the 15, the 18, the 30. You have a question? The other way to look at this is if you made it into a little table. And this is just another way that they do coordinates, is they make it as a table. And we'll just follow it with it exactly the same way. But it would be like 1 to 5, 2 to 10, 3 to 15. If you're starting to understand what the rule would be for it. So sometimes you'll see where we list the coordinates. Sometimes you put the coordinates into a table. And then we're going to draw two examples of what you might see on a graph or a grid. So here's going to be my grid. And I'm going to use red. And I'm just going to say, here's my line that went through. So some of the coordinates. Now when I look at this one, this is where that pencil test comes in. If I do my vertical line just like this and I go across, my pencil only touches one part on that line. It doesn't hit two places. Look at the same thing. I'll do one more down here, small, where I can even do this little bell curve kind of one. But it still is only going to hit one. It's a lot closer because that bell curve is almost straight up and down, but it's curved the whole time. So when I come down, I'm only hitting through one coordinate. go ahead and look at our non-examples. Which ones prove that this is not a function, which this will make our work a lot quicker, is we'll do the first where I lift the coordinates. I'm going to do these in blue to make sure we see that there's a difference. But if I did like coordinates 4 to 12, 4 to 15, 5 to 17, 6 to 21. You're also going to see that there's no rule that's being applied here, which is why it's not becoming a function. These are just random coordinates that I'm giving. But my x coordinate 4, which I see, switch, right here and here, it went to 2 of different coordinates. The same coordinate x went to 2 different y's. We cannot have that to be a function. So that's the quickest way. If you look and see, hey, my x goes to 2 different y's, or my y goes to 2 different x's, then it's not going to work. It's not a function. The table, I'm not going to draw the table if you want it. It's the same thing. Just put your x into 2 spots. But let's look at drawing a graph. Make my grid. Use this blue. Easy one would be something like this. If I did my pencil test and I did my vertical line straight up and down, I can see, and I'm going to mark it with red where the failure would be. I can see like right here and here, my x coordinate is hitting the same, or hitting a spot of 2 different y coordinates. Here and here and here. The x is hitting more than one y coordinate. So that is not a function. Oh, if we did this bell curve, but we did it left to right, like that, that would not be a function, because pencil test, here and here, the x coordinate hits more than one. Does that make sense? You guys kind of getting the feel of a function? Okay, we'll end up gluing those on our spiral notebook. We'll make this kind of like our homework. We'll set it up a little bit later. You'll probably have the end of class. I just don't want to take all of our time to be gluing right now. So make sure you hold this sheet. Just put it to the side. I'll glue mine into my notebook with you, just so we're staying as organized as possible. You're going to get another sheet that we're going to go in there. Okay. I'm just going to give you a stack of them. You'll probably have extra. Just make sure. Let me know. Alright, so this sheet, DIX, and then ROY, we use this to help us understand the domain in a range. Because when we get coordinates, I'm going to go ahead and just write one over the side, like 4, 7. You're going to see a lot of the math terms that we give you, they'll be very specific, and we want to make sure that you know the different names. So when we look at this, I want to make sure I pull something up for me. Alright, right here, the D is going to stand for domain. Your domain is going to be the first number of your coordinates, the X. The I colors is your input number, and then the X is simply the X coordinate. You'll refer to that first value of our coordinates as 3 different names if you want. It could be known as your domain, it could be known as your input, it can also be known as your x-coordinate. The second one is known as your range, your output. My output, or my y coordinate. And to be honest, I'm not going to write this whole definition. I think that's going to take longer. It's mainly just what we're saying out loud. This first value, you got to actually just, the first value is your domain, input, or x coordinates. So here in a little bit, we're going to say, what are all the domains? And you just have to look for the x coordinates. Or they're going to say, what are your input numbers? You look for your first coordinate. Or what are your x coordinates? You look for the first one. X coordinates always listed first. So we graph, we run. We go left to right on the grid plane. The y coordinate is going up and down. It's on the y-axis. We'll also glue this in our notebook here in just a little bit. Alright, so pretty easy this one. This should take about a second. Let's make sure we just understand this part. Identify the domain. Alright, so I'm going to write domain. So we want to go ahead and identify our domain. Well, what do you think our domain is? Zoe? Okay, what are those numbers? All I have to say. The domain is going to be 0, 1, 2, and 4. I like when they ask these questions. So that means your range is then what? 5, 2, 2, 1. Real quick, what can we tell already? Because we just looked at our domain and range, you should be able to understand something about this. Is this a function? Why not? Okay, because there's no pattern. Yeah, go ahead. Good. Right here, it's going from 2 to the same y. So that's not going to work as a function. You're right, there's no pattern, there's no rule that we're establishing. And then our x coordinate went to 2 of the same y's. So we can't have 2 x's go to the same y. Whew. Last foldable that we have to put into it. Alright. We are going to use this next one, I believe, if I did this right. Where did I go on this? Okay. I'm going to switch right over to here because I want to make sure. Let me go to my sphere. Okay, on your sheet that you have here, we're going to try and make sure that we understand what all this looks like. So, first thing, the difference. This is just different ways that we write our domain and our range. The first thing is we can have ordered pairs. So, I'm just going to go ahead and do this, like 1, 2, 2 to 4, 3 to 6. I'm going to do just 3. This is how we're listing our ordered pairs. You put the parentheses around so you know which ones go together. If we made it as a table, it's kind of like the input-output, X and Y. If 1 went into X, 2 came out for Y. If 2 went in, 4 came out. 3 came in, 6 came out. A mapping diagram, what that usually looks like is where we just list them. And they draw them, just point it over. The nice thing is sometimes with the mapping diagram, they don't have to be written like the coordinate points. Like your line doesn't have to go straight across. It could have went down. Especially if it's not a function. Like maybe if this one wasn't a function, I'd say the 1 also goes down to the 6. If all we're doing is having a graph. And then of course, the way we graph it. Remember, with your coordinates, the x-coordinate is the one that goes along the x-coordinate line. Pen. So you run first. You run left or right first. It's a positive 1, so I go over 1. The y is a 2, so I go up 2. 1, 2. I go over 2. I go up 4. And I go 3, 6. Oop, that end up there. Which should allow me to make a straight line. My line ain't real straight. I should have used the ruler. But the beautiful thing is, once you've graphed 3 coordinate points, I can now find lots of other coordinate points. All I have to do is look at where it is. Right here, I can see that on this function, this point right here would be a coordinate. It is 1, 2. It's going to be like -2, -2. If I drew my line correct. My line's a little crooked. It's not going to line up. But when you have a straight line, any point that falls along that line is part of the function and will be part of your ordered pairs. You have to do 3 to make a straight line, and then any of them that fall along that line. Okay, and then the last part, pretty simple. What was our domain that we used? Our domain was what, Zoe? Yeah, domain was 1, 2, and 3. And one of the 3 Katie's, what was my range? Good. Two, 4, 6. I got a feeling I'm not going to completely finish everything today because, like I said, first day of grading homework took us longer. So make sure you hold on to these. My goal is tomorrow we'll go ahead and glue them into our notebooks. I'm going to keep going until closer to the bell. But but I don't think we're going to get through our assignment all the way. So we'll just finish it up tomorrow. Let's continue on in OneNote. Is it still not working, Devlin? Okay. Alright, let's see what we can do here. Tell whether the pairing is a function. So what do we think with this one? I see my input domain x coordinates are 2, 2, 4, 7. My output 0, 1, 2, 3. Is this a function? I hear no. Why? There's no pattern. I like that. Good. X coordinates, I had 2 of them, and they went to 2 different y's. So, very easily, not a function. I don't know why I'm writing with a highlighter right now. Make a table for a function. Now, this is where I said you're pretty much doing the same thing as yesterday, but when we evaluated expressions, except now you're going to do it probably about 4 times. When we look at this, it says the domain, remember domain is our x coordinate, the domain of a function y equals 3x. Okay, it gets a little confusing, but if I highlight that, function is y equals 3x. They're telling me what my function of the table is. So don't mix them with the other numbers. I know right here where I look, my y coordinates is just 3x. So if I put any value in for x, I just have to evaluate 3x, and that gives me what the y is. Here they told me specific. They said the domain is 0, 1, 2, 3. I'm going to highlight that in yellow so it matches up with the domain. So I go to my table and I just go 0, 1, 2, and 3. That was my domain. Then I have to go to my range. Well, to find the first one, if 0 went in, here's the function right down here. So I do 3 times 0, which is 0. Okay, so my first y coordinate is 0. So it goes 0, 0. I put in 1 here. So now I have 3 times 1, which is
3.
And then I have to put 2 in. So 3 times 2 is, and I put 3 in. 3 times 3 is, the range is 0, 3, 6, and 9. I think the hardest part is just when you read the question, break it up, because when I first read the domain of the function y equals 3x is 0, 1, 2, 3, I'm like, what just happened? But if we break it up, the domain is 0, 1, 2, 3, the function is y equals 3x, all you're doing is evaluating the expression. Let's stop with this one. This will be the last one, and then I'll look at your homework that we'll assign tomorrow, because I'm not going to give you this homework because we're not going to finish, but we'll just catch it up tomorrow. We'll kind of go a little quicker. So remember, tomorrow, get in here. As soon as that tardy bell rings, we're starting class. It took us a little longer. If we had that 10 minutes, we would have been right on time. To be honest, we're not going to get this one. We have about 30 seconds. So, important. I'm not giving you a homework now, but we still are going to have to do it. So it means tomorrow, remember, we told you algebra is fast-paced and we can't take breaks. I can't say, well, we'll do this tomorrow, we'll just do all our plans today. We are going to have to catch this up tomorrow. You can start looking at it if you want to. She asked a good question. If you want to look at the homework, because you think you're catching it, it is listed here. We're going to do one in the book and one worksheet. I'll look at it with you tomorrow, but maybe we'll catch up. Oh, by the way, I have an algebra book that was left in the classroom that's on the safe seat. So if you left yours, let me know.